Good evening, everyone. Yeah. So, what's the update before assignments? Have you done any of the assignment? Hmm? How many sessions completed? No one asked for counters assignment. Have you not gone through the counters? I thought you will ask the counters assignment to practice, but no one asked.
Ma'am, today only I got my new laptop, ma'am.
Okay. Okay. What about remaining? Did we discuss about blocking and non-blocking assignments programming?
No,
Okay.
are you
So
able
what about
to?
hmm,
I mean,
yeah,
are you, am I audible, Prashanti?
yes.
Okay. Yeah, yesterday I tried for up down counter, but when I'm trying to structural, I feel little bit tricky. I thought to ask one small program,
Small program in the sense.
like a simple program ring counter. I thought, but when I tried with the D flip flop, the output itself, I'm getting little bit confused. By the end of the class, I will show my program.
Okay. You have tried in
Mm.
structural modeling, huh? For
Yeah,
the
yeah, yeah. Yesterday I
how to
tried.
counter, huh?
Sorry.
For counter, huh?
Yes, yes.
But for counter we don't use D flip flop, right?
Ring counter. I tried for three T flip flop also. I tried, but before that, when I tried for the D and T flip flop, the outputs itself, I felt little bit not understandable. So I thought to
Okay.
discuss with
Have
you.
you referred the flip flop programs? I have shared flip flop programs.
Yes, I have referred, but yesterday I felt little bit confusion.
Okay. Fine. No
And
problem.
up down counter I have written. That is also I understood the output also. But here
Okay.
output I felt a bit confused. That's
Okay. Fine.
yeah.
What
Thank you.
about remaining? Today I will share you the counters assignment also, so you can try that. And okay, blocking and non-blocking not discussed, right? So what is the difference between blocking and non-blocking assignment? What is the difference between blocking and non-blocking assignment?
Hello.
Yeah, hello.
Yeah. Blocking assignments are used in combinational circuits and non-blocking are used in sequential circuits.
Okay,
And blocking assignments, when we assign the statements are executed one by one, and non in non-blocking assignments the statements executed and parallelly.
okay. Still, why we use a blocking assignment for continuous only? Why not for I mean, why for combinational? Why not for sequential?
For example, like in register that parallel out, we need the parallel operations. There, we need non-blocking assignments
Okay.
and many other synchronous where there is a synchronous. I think so. Yeah.
There will be a synchronous. Okay, fine. So we will discuss clearly blocking and non-blocking assignment with the examples today. So first of all, blocking assignment will be represented with is equal to symbol. Okay, so is equal to symbol, and non-blocking assignment will be represented to with this symbol. Okay, so first where we write these blocking and non-blocking assignments. Okay, in procedural assignment statement, we use the blocking and non-blocking assignment statements. Okay, what are the procedural assignment statements, Sunny or Sai? What are the procedural assignment statements?
Always.
Hmm?
Always.
Always. Okay. Next.
Initial, always or
Initial.
initial are
Initial.
Huh? What? NaCl.
Initial.
Initial. Okay. Okay. So initial and always block. Both are procedural assignment statement. Okay. So in which case we use begin and so when there are multiple number of statements within initial or always block, whenever there are multiple number of statements, here we use begin and block. Here also we use begin and block. Okay. So these non-blocking, so assignment, first of all, if you see the name called assignment in the sense here RHS side values, right hand side or the RHS side values. So RHS side values we will assign to LHS. So here we will assign to LHS. Here also we will assign to LHS. That means A is equal to 10, B is equal to 20, C is equal to A plus 10, A plus B, like that. Okay, so these 10 or 20, A plus B, all these are right hand side. Okay, so how you're assigning some RHS side value to the LHS side value? Okay, either through blocking or non-blocking, how you are assigning the value. That's what we call as a assignment. We differ with the assignment. Okay, same here also. Within either always block or initial block, both we use. Within initial block we use either blocking or non-blocking. Within always block we use either blocking or non-blocking. Okay, both we can use in the both statements. Okay, so here also A is equal to B plus C, B is equal to C plus A, D is equal to A plus 10. So or whatever RHS side variables are there, those things we are assigning to the LHS side variables. Okay, so that type of assign. So how you are assigning some right hand side value to left hand side, that's what we call as a blocking assignment or non-blocking assignment. Okay, so first of all we will see the difference, how they are working, and we'll see the output, and then we'll discuss why blocking assignments only used for combinational logic circuit, not for sequential, and why non-blocking assignments are used only for sequential, not for combinational logic circuits. Okay, so before that you need to remember few statements, few conditions. However, we use some conditions for procedural assignment statement, continuous assignment statement, right? So same as for blocking assignment. First thing is a blocking assignment will be represented with the is equal to. Okay. So whenever one single statement is executing, remaining all statements will be block. Okay. If one statement is executing, remaining all statements goes into block. Remaining all statements will block. Okay. And also blocking assignment statements will execute sequentially. Sequential execution. Okay. And right hand side value will be updated to the next statement. RHS side value will be updated for every time unit. Okay. So these are the statements you need to remember. One is if one statement is executing, remaining all statements will go to blocking as a block, and all the statements will execute sequentially. RHS side value will be updated every time. That means it returns a previous value. Whatever the variables are there, it retains its previous values. Okay. For non-blocking assignment, it will be represented with this. Okay. So if one statement, all statements will execute concurrently. Okay. All statements execute concurrently, not parallelly. We cannot say it's a parallel. Okay. So parallel means a fork join. Fork join will execute parallelly, but non-blocking assignment, a fork join, if you observe the output, both the differences, it looks similar only. Okay. There will be no much difference in the output, but execution wise, whatever the statements we are writing in the non-blocking assignment, those statements will execute sequentially only. Okay, because we are writing in the begin and block. So whenever we write some statements within the begin and block, those statements definitely execute sequentially. Only whatever the statements we are writing in a fork join, those statements will execute parallelly. Okay. But coming to the non-blocking assignment, even if we write in the begin and block, as they doesn't retain its a previous value, and also the before simulation time will not add it to the next statement. That's why it looks like a parallel execution, but it's not like a parallel execution. Okay. So another step in a blocking assignment is uh, time unit. Simulation time will be added to the next statement. Simulation time will be added to the next statement. Okay. So here all statements will execute concurrently, and the variables doesn't retain its previous values. Most important interview questions. It doesn't retain its previous values. Okay. And also sequential concurrent execution, and RH side variables doesn't update. Doesn't update. That means it doesn't retain its previous value. Doesn't update. Whatever assigned value is there, initialized value, it will be executed with the same value for entire process. With the same value. Okay. And the simulation time also not added to the next statement. Okay, everyone note down these rules. Okay, did you all noted these things? Everyone? Hello.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so I will give you one example. So let me know what will be the output. Okay, so I'm taking A is equal to A is equal to 10, B is equal to 20, C is equal to 15. So for blocking assignment, I am writing begin. Okay, so first example is for blocking assignment. Second example is for non-blocking assignment. For non-blocking, we can put like this. And also for non-blocking assignment, we need to take the these um, delays at left side. We call it as a inertial delay, and tomorrow get what is the difference between okay, so I'm writing again for non-blocking assignment begin, or else I will write in EDF background. Wait, there we can do simulation directly. Tomorrow in Verilog we have a few delays. Note down everyone. Inertial delay, intra-assignment delay, inter-assignment delay, regular delay. So what are the differences between these? Get the answer by tomorrow. Okay. So begin. A is equal to 10.
Can you repeat once?
Equal to 15.
Can you repeat once those delays?
Inertial delay, intra-assignment delay, inter-assignment delay, regular delay. Hash 5, A is equal to B plus C. Hash 1, B is equal to A minus C. Hash 3, C is equal to B plus 10. Hash 7, D is equal to A minus 15, hash 4 is equal at 4 time units, so A is equal to A plus B. Okay, so here I used end. Here I used a blocking assignment, and down I am using non-blocking assignment. Okay, so for non-blocking assignment, we need to use like this symbol, and here also for every assignment. That is how we will differentiate with the blocking and non-blocking assignment. So here hash 5, whatever left hand side variables or time delays are there, we need to use right hand side. Even you can put left hand side and check what will be the output. Okay, so here you need to understand what happens if you put left hand side and what happens if you use the right hand side, like at what time it is executing, and also assigning the value. Execution will be at some time, assigning RHS side to LHS side value at some time. Okay, so that for that purpose, I'm telling you to know the difference between inertial delay, intra-assignment delay and inter-assignment delay. Okay, now I have written few points here, right? I think you already noted blocking means if one statement is executing, remaining all statement goes into block. It block all the statements. So first statement, all the statements will execute sequentially and retain its previous value, and simulation time will be added to the next statement, every statement. Coming to the non-blocking assignment, all statement executed concurrently and variables doesn't retain its previous values, or HSI variables doesn't update with the previous value. It means both are same. So whatever initialized value is there, it will execute with the same value for entire process, and simulation time is also not added to the next statement. These are the conditions. So according to that, tell me what is the output of first statement and second statement. In the first, for blocking assignment, so at what time which statement will be executed and what will be the output of the LH side variable. Once again, read all the points and tell the answer. Fast. First think, all the statements execute sequentially. So which statement will execute first and what is the output? And the delays will be
First
added to the
statement,
next statement.
first
Yeah.
statement will go first.
Okay. What is the output and what is the simulation time?
So after 5 time unit,
Okay.
a value will be what is that? B plus C 20,
Okay.
and then B value after 6 time 6 time units.
After 6 time unit.
Yeah. So B value will be 20 minus 5, that is 15.
Any other answers from others? Lahari, Rakshita, Aditi, Sunny, Sai, Sumrata.
Same answer.
Okay.
Same
Next.
answer.
Yeah. Can you tell Sunny or Sai who replied now? What will be the next output and what time?
after 9 cycles, 9 time units.
At 9 time, not after 9.
C will be 25.
C will be 25. Okay.
And after 16 time units, D will be 5.
9 plus 7, 16 time units. So D is equal to 5.
5.
A value is at 20. 20 minus 15, 5. Okay.
And after 20 time units,
At 20 time units,
A will be 35.
16 plus 15. Okay. A is equal to 35. So A is equal to 20 plus 15, 35. Okay. Is that correct? Everyone, any doubts here? Any doubts in this case?
Ma'am, once again, please repeat me, ma'am.
Okay. So, so how did you got this output in the sense? First of all, we need to follow one rule. All statements will execute sequentially. Sequentially means what? First, this first statement will be executed. Second, this third, next, fourth, one by one. Sequentially, we will get in a order. Okay. So I told delays will be added to the next statement. So here first initially fifth time unit, this statement will be executed. 5 plus 1 is 6. 6 plus 1 is 3. 6 plus 3 9. 9 plus 7 16. 16 plus 4 20. Like that each statement delays will be added. Okay. Next thing what I told, the value will be written. It's a previous value. Okay, so A is equal to B plus C. So 20. Okay, now A is updated with a 20 value. So that updated value will get here. A is equal to 20. So 20 minus C. What is the C? 5. So 20 minus 5, 15. So B will be updated with the 15 value. That updated value will get here also. It retain its a previous value. Okay. So 15 plus 10, again 25. So C will be updated with the 25. Okay. So D is equal to A minus 15. A, what is the value of A before updated value? Not initialized value. You need to consider updated value. Okay. So what is the updated value? 20. 20 minus 15. It's a 5. So D is updated with a 5. And A is equal to A plus B. What is the value of A? Updated value of A here, which is a 20. Next, B, 15. So 15 plus 20, 35. Clear, everyone?
Yes, ma'am. Okay.
Next, Rakshita, can you tell output of non-blocking assignment? Follow the conditions, whatever we discussed before.
Okay, ma'am.
First, sequentially, the statements will be executed, but delays will be not added to the next statement. And also, it doesn't retain its previous value.
A is equal to 20, ma'am.
A is equal to 20 at which what time unit?
5.
Okay. Next,
5.
what 5?
15, ma'am.
What 15?
B is equal to 15.
B is equal to 15.
Yeah, ma'am.
How?
Updated value minus.
I told in non-blocking assignment, it will not consider the updated value. Whatever the initial
Okay.
value is there, the initialized value will be considered for entire process.
Then B is equal to 5, ma'am.
B is equal to 5. At what time unit?
1,
1. Huh?
1.
Is that correct, everyone?
Yes.
No, Prashanti.
Okay. Then what time?
No,
First
6.
at first unit B equal to 5. That you need to write first.
First?
At first unit B equal to 5.
Okay.
Then third unit C equal to 25.
Okay.
And at fourth unit A equal to 25.
Okay.
And at fifth unit A equal to 20.
Directly it will add. So you are telling it's a parallel execution. It's not parallel
Yeah.
execution here.
Okay.
It will not execute parallelly.
Okay.
Ma'am,
One by
hello.
Yeah.
Yeah,
Hello.
these statements are executed parallelly in the sense every one cycle, every one clock cycle, the B value changes. Right now,
Every one clock cycle, B
So,
value will be changing.
for every one time unit.
Whatever or time unit or whatever. So every one time unit, B value is changing. No. It, here, how many times of execution we are writing? How you can tell it's a one time at every one time? Suppose I am writing this beginning block in a initial. Here also I am considering initial. How many times will execute initial block? And how many times a always block will be executed?
initial will execute one time.
Okay. What about always block?
Always block till the condition if we mention any condition.
Okay. So here all the statements will execute only one time, right? Until unless if you write a repeat of 5 times, repeat of 10 times, if you write like that, then the statements will be executed multiple number of times, or else it will execute only one time. That too, in that case also, even if you write repeat block, every one time unit the B will not execute. First, it will execute entire process, entire all the statements. First, it will execute. Then it will repeat again from the first statement. Repeat 2. All the statements will execute in repeat 2. Again repeat 3. All the statements. Again repeat 4. All the statements. Like that the execution flow will be there. Okay. Fast. What is the output here?
And in this case, the even the
Other girls,
execution times also is not affecting, right? So
what time?
simulation time also.
Simulation time also will
Timing is not affect. Okay, then the first one is the same. I mean, A equal to 20,
okay.
and B and
B is equal
to 5.
5. Okay.
Yeah,
Next, C is equal to
and C equal to B plus 25.
B is 15 plus 10, 25. At what time unit?
And at the same 3 unit only.
At 3 time unit, B is equal to 25. Next, others. Can anyone answer? Vinita?
At
C.
7
This
time
is C.
unit,
This is C equal to. This is
A
not
is
B.
equal
C
to
equal to.
C equal to. Okay. Remaining?
at 7 time units, D equals to -5.
A is 10 minus 5, 15. Minus 5. Okay.
And at 4 time units, A is equals to 25.
Okay. 10 plus 15, 25. Rakshita, is it clear? Remaining all. Any doubts? Did all conditions satisfy? First of all, the statements will be executing concurrently. So, however, I have written delays here: hash 5, hash 1, hash 3, hash 7, hash 4. These are the execution internally. This is how the statements execute internally. But while coming to printing statement, hash 5 statement will not print first. Why? Because hash 1 is there. So first hash 1 will be printed, then hash 3, then hash 4, then hash 5, hash 7. Like that the values will be updated. Okay, but in internally execution at runtime, if you see the execution process, it will show in a concurrent way. First A, B, C, D, A. Okay, but while we are when we are writing at the output statement, it will print according to the delays only. Okay, 3 conditions satisfied. First one is a concurrent execution. Delays will be not added to the next statement, and also it doesn't retain its previous value. Whatever the initialized value is, that will be updated with the same value. Okay, clear everyone?
Yeah, yes, ma'am. Yes, ma'am.
Okay, so we will do the execution of that. I'm considering this first example. So how we can write the program? Module. Did everyone got programming style? Are you able to write your own program? I'm declaring all the variables with the registered data type with the 5-bit size or 6-bit size, whatever. So initial begin A equal to 10, B equal to 15. Next. I'm writing dollar monitor dollar time. First write dollar time, comma, A equal to percentile B. So what is the percentile B format specifier? What is a percentile B, percentile D, and percentile G, percentile H, percentile W, and percentile O? Did you know all these differences?
B is for binary,
Okay,
percentage D is for decimal,
okay,
percentage H is for hexadecimal,
okay,
percentage W is for word, I think.
okay.
Percentage S for any string.
W word. Do we use word in this?
Not sure.
We don't have W actually. We'll have M, percentile M.
And O for octal, I think.
M
Percentage
and
octal.
G. What?
Percentage O is octal.
Octal. Okay.
This I know.
G. In the first session we discussed in data types, Sai and Sunny. Can you explain? G. What is G?
It's for floating data type.
H for float. No. Remaining. G. What about G?
Real, ma'am.
Real. We print the decimal values, real values. Okay, float values. We can also call as a float values. Okay. So here I'm just run the syntax error. D also return. Okay. We will print in a decimal. Binary means we don't know 5-bit binary values, right? So we print in decimal. I'm just making it as a D, and for B also, C also. Okay, so check here. Total how many statements are there? Okay. So initially at 0 simulation time, A is equal to 10, B is equal to 15, C is equal to 5. Next at 5 simulation time, A is equal to B plus C. So 15 plus 5, 20. And the B, C remaining it's a previous value only. Next 5 plus 1, 6, 6 plus 3, 9. At 9 time unit, C is getting updated with the 25. C is equal to B plus 10, 25. 9 plus 7, 16 plus 4, A is getting updated. Values are missing here. Initial begin dollar monitor values are missing.
You are not printing the D, Prashanti. Only D till C.
2 values are missing. Internal values.
In the monitor, try to print the D also.
So initially at 0 simulation time, A equal to 10, B equal to 15, C equal to 5, whatever we assigned. D we didn't assign any value, so X. At 5 simulation time, A is equal to B plus C. So 15 plus 5, 20. B and C, D will not update. Okay. Next 5 plus 4, 9 simulation time. 9 plus 7, 16 simulation time. This 9th simulation time is not printing. 16 simulation time, C is equal to B plus 10. C is equal to B plus 10, correct. 16 plus 10, D is equal to A minus 15. A is 20 minus 15, 5. So D is updating 5 correctly. And 26 plus 15, 41. At 41 time units, A equal to A plus B. So A equal to A plus B. 20 plus 15, 35. 35 is printing properly. Okay. So middle, this 7 is missing. We will change tool. Here also same. Most of the
Can you
cases,
change that time unit 5-4? Give the little bit higher value at B. At B.
same. Okay, we will check that statement, or else I am just removing this. 5 plus 10, 20, 15, 15 plus 15, 30. At 30 time units, it is printing. 10th value is not printing this 10th value. 0, 5, 5 plus 5, 5 plus 15, 20, 20 plus 10, 30, 30 plus 15, 45. Okay. And A is equal to B plus C, getting correct. And C is updating here 25, and D is updating A minus 15, and A is equal to A plus B. That's what the blocking assignment statement. Everyone understood? All conditions satisfied? Hello. So if you write a repeat here, initial repeat of 3 times I'm repeating. So entire this process will repeat again. Okay, run. See. First 0 to 45. Again 45 plus 5, 50. Okay, first one 5 only, right? So 45 plus 5, 50. 50 plus 15, 65. 65 plus 10, 75. 75 plus 15, direct 15 value is printing 90. Sometimes the internal delays, due to some delays effect, we'll have the analysis, timing analysis, right? Based on that, it will internally, tool will miss some values, okay, because of the delays. So, but that is how the blocking and non-blocking statements, blocking statements will execute. So it is repeating 3 number of times again. Did you understood everyone till here? And also you can check with the output and again whatever repeating second time. So what is the A value, B value, C value, whether it is preferring updated value or initial value. Just check it. Okay, clear till here? I have written a lot of examples in PPT also. Whatever the PPT I have shared, I think this PPT I didn't share to you. Today I will send. Okay. So coming to the non-blocking assignment statement, suppose same I'm using, just I'm changing the symbol here. Instead of blocking, I'm just changing this symbol. then what is the output? Output will not change anything in this case. Okay, for non-blocking assignment, you cannot use this delays left hand side. You must use RHS side delays. Okay, but we will check once. So in blocking assignment, we got 5 plus 15, 20, 20 plus 10, 30, 30 plus 15, 45, like that, right? And also values returning its a previous value. But in non-blocking assignment, we will get same like this 5, 10, 15. At 15 time units, both values will be printed. That too, because of 15, at same time both values will be executed, but we'll get the final result. So instead of that, we will put as a 20. Okay, so two values will be printed. So first fifth statement will be printed, next 10, next 15, next 20. Like that it will be printed. Okay. But in this case, it will print normally. Why? Because I kept delays left hand side only. First we'll see this, and then we'll change the delays to right hand side. Okay. See here, 0, 5, 5 plus 20, 25, 25 plus 10, 35, 35 plus 15, 50. Again 50 plus 5, 55, 55 plus 20, 75, 75 plus 10, 85, 85 plus 15, 100. Like that it is printing, blocking assignment. Okay. So that's why we need to put delays at right hand side. Everyone understood till here? Any doubts?
No doubt, ma'am.
You need to attempt the test also. You're telling no doubts, but how much you got in test? Anyone attempted? That's up to you. I can't do anything. So see here, what is the result? Zero simulation time, 5, 10, 15, 20. Like that. Okay. So what is the zero simulation time? 10, A equal to 10, B equal to 15, C is equal to 5. D not assigned. So at 5 time units, A value will be updating, right? B plus C. So 20. Okay. Next, at 20 time units or at 10 time units, D is equal to A minus 15. So what will be the A minus 15 D? So A minus 15. 59. Okay, what is the A value? A value is a initialized value is a 10 now. Okay, minus values will not print here. That's why it is. Okay, suppose A minus 5 I am writing because here minus values will not print, right? We took as a bridge. Yeah, now it's getting up. So what is the A value initially, not updated value? Updated value is a 20, but we don't consider the updated value. Whatever the initial value is there, that thing we need to consider. So A equal to 10, B is equal to, D is equal to 5, correct. Then A is equal to A plus B, not updated value. Whatever 10 is there, that 10 plus 15, 25. Okay, so 10 plus 15 or 25, but it should not consider 25 plus 15, 20 plus 15. Okay, this is what we call as a non-blocking assignment statement. Clear, everyone? Any doubts? Hello,
No, ma'am, no doubt.
everyone understood blocking and non-blocking?
Yes, Prasanth.
Suppose I'm considering why we need to use blocking for combinational logic circuit, non-blocking for sequential logic circuit. That's what our question, right? Suppose I'm using a register. Okay, serial input, serial output, shift register, suppose. How do we write the program for serial in, serial out, shift register? So here we will consider as a D input, whatever Q output we get, that same output we will send here. Okay, and that's what we call as a Q1, and here Q2. Whatever Q2 is there, we will send same output to here and here also. Okay, so in that case, if we write the D is equal to, or else Q is getting D value, and Q2 is getting Q1 value, Q3 is getting Q2 value. Okay, so can you do analysis and tell me what will be the output diagram for both cases?
Whatever the D input is there, that will assign to all.
Okay, whatever D input is there, that will be assigned. So in
Means D is
combinational,
assigned to. No.
okay, so D is a 10. Q also will get a 10, and this will be getting here 10, and here also getting 10, and here same value will be getting 10, and here same value will be getting 10. Okay, so without shifting, it is not doing any shift operation. Whatever the input is there, output is also getting same value. It is just giving one block diagram. It is not doing any shift operation. Okay, but in same way, I'm writing a non-blocking assignment. Q1 non-blocking assignment D. Q2 Q1 Q3 Q2. So what is the output in this case?
Here also same output, but here the all statements must be executed. After that only
How do you get
value will
same
be.
output here?
See, here D is assigned to Q.
Okay,
D
because
is assigned with
we
the 10.
Yes.
Q1 will get a 10. So here what value will get for Q2?
but it will not update take the updated value. Q1 should be
Yeah.
initialized with some value.
Hmm.
No, that will after execution of all the statements, values will be assigned, I'm telling.
Okay, Q1 will not get this value. Whatever the Q1 have some initial value, that
Hmm.
value will be assigned to here. This value will not shift to here. Suppose Q1 is assigned to 5 value or some previous state value. That 5 value will be getting here. Like that, this Q2 value will not updating here. Whatever the Q2 initialized value is there, suppose initialized with a 4. That 4 will be updated to Q3. Okay, so in that case, even if it is a, you may think like in serial out, it may not possible. But if you take parallel in serial out or parallel in parallel out, okay, here block 1, block 2, block 3. So D1 and D2, D3. So in this case, it will generate proper shift register, right? One data here D1 or else Q1, Q2. Directly these data is getting shifted to output. But same parallel in parallel out case, if you take for combinational logic circuit, will it generate the this type of shift register circuit? This is the most important thing to understand. So everyone try this example in synthesis tool, quarters prime. Okay, everyone write the program. Just Q1 is equal to D, Q2 is equal to Q1, Q3 is equal to Q2. Using blocking assignment, no need to use any delays. Just we are doing synthesis only to check this circuit diagram. Okay, Q1 equal to D, Q2 equal to Q1 using non-blocking, Q3 equal to Q2 using non-blocking. Okay, how you will write the program? You can use always at the rate of POSH block or whatever initial block. Initial will not synthesize, right? You can use always at the rate of POSH block, generate a clock and write a module inputs, input D. Okay, and generate the circuit diagram and show me what will be the synthesizer netlist. Okay, everyone clear till here? You need to show by tomorrow. If you don't get, I can write directly. Even if it generate multiple blocks, how the input is assigning, you need to observe. Shall I write now or you will try? Huh? Will you try? And next thing is, next example is swapping operation using blocking and non-blocking assignment. So how you can do swapping operation? Suppose A is equal to 10, B is equal to 20. After doing swap operation, A should get 20, B should get 10. So how we can write this swapping operation using blocking and non-blocking assignment? Very simply. Normally in C language, how we will write, we'll take one temporary variable, we need to do addition operation and then subtraction operation like that. But in Verilog, we can do very simply. So how we can write? Just think of.
Directly we'll use non-blocking statement. A less than or equal to B, B less than or equal to A.
Okay, so if you want to use a blocking assignment, then how we can write?
Like A equal to B plus C, B equal to A plus A minus C, some and
Okay.
A equal to, like, we'll use three statements, I forgot.
Okay.
Either using
So,
plus or minus or XOR symbol we can do.
okay. Is there any need of temporary variable?
No.
Directly you can do the addition and subtraction. No?
Yeah.
Okay, fine. So like that we can also do, or else we can use that temporary variable. So first we will store A data into some temporary variable TA equal to A, and then temporary variable B, TB equal to B. So then you can assign B equal to TA and A equal to TB, like that. Like this we can use the temporary variable, but this is one of the drawback with the blocking assignment. Okay, so if you use a non-blocking assignment statement, directly we can use B is equal to A is equal to B. This is what non-blocking. Same thing I'm writing using blocking assignment. A equal to same how I can write. B equal to A equal to B. Now we'll check. So here, what is the value of A? A value is 10. What is so 10 will be assigned to B. In non-blocking assignment, it doesn't retain its previous value, so this value will not be getting to here, right? So what is the previous value? 20, I mean initialized value. So that 20 is assigning to A. So interchanged. A is getting B, B is getting 10, A is getting 20, interchanged. But if you use blocking assignment, what is the value of A? A 10, no? So B 10. In blocking assignment, this value will be written here. It stored previous value. So B is 10. Again, A also getting 10. Same value is getting. So it's a wrong. We can prefer non-blocking assignment to do swapping operation. Okay. Same you can try in this example. However, we tried, same you can do. So these are the assignments for tomorrow. One thing is you need to do the synthesis and check the synthesis result, both the netlist for blocking and non-blocking. And second thing is you need to do the swapping operation using blocking assignment and non-blocking assignment. See, simulation result and synthesis result most important. You need to submit. Otherwise, your points will be decreased in certification. I already told you. All the assignment marks will be added for certification. At least half of the assignments you need to submit. Any other doubts till here?
Prasanti, like I'm using EDA tool from Google only, like from my email ID only, that free version of that. So how can I do the synthesis?
Quartus Prime we already installed. You
Uh,
haven't
no,
installed.
no, I have told you know like mine is
Okay.
Mac
No
operator,
problem.
so
I already shared the recorded sessions, right? In that recorded sessions, you will find that tool access, how to install the tool installation guide. Just go through that and install. If you don't get, I can explain you.
yeah, Miss Santi, but mine is for the Mac operator. That's why that's why
We can't do
that's why
anything for Mac. You
yeah,
need to
that's
do
why I'm using the
machine.
EDA playground of using
Okay.
Google. Yeah.
But for Mac, I tried lot of tools, but no one will work. I even installed that what we say that media like another OS also Windows also I installed in Mac. Tried with the Quartus Prime, but still it is hanging laptop. Lot of
Yeah.
hanging issues we are
Mm.
getting. So I just removed that laptop only because for tools.
Yeah, I have this laptop only. That's why I'm using that.
Okay. Okay, no problem. Whatever
Uh,
the program you write, just let me know. We share to me. We do the synthesis and check. Okay.
okay,
Or
sure.
else you can have the meet with anyone in your group with the Sumalata or Aditi. I think Aditi also from US. You can contact. Okay.
Okay, sure.
Yeah.
And so simulation for the registers, right? And the swapping assignment, both.
What?
Like for the registers you asked, right? Uh,
Synthesis, huh?
simulation and synthesis for the registers that
Yes. Yes.
serial out
Today
and
I will share
parallel.
you the counters also. Everyone practice the counter and do the assignment. That is one of the best assignment for counter. Hi Sagar, have you attended from starting of the session? Are you there? Okay, Sumlata, I think you have some doubt. Can you share your screen?
My screen is not the same issue. I'll share the EDA link.
Okay, you can share in the chat box.
Yeah, 1 second.
Remaining Lahari, Rakshita, Sunny, Aditi, Sagar, any doubts?
No
So
doubts.
today we have completed blocking and non-blocking assignments clearly. I think everyone understood. But just try to write the program. So if you don't get that, we will do synthesis in the next week. I mean next session. and also we'll do the swapping operation. Okay, just try from your side. Mostly in the next session, we will complete the generate block, latches, and verification concepts. We'll have the long session on Monday. So we will complete all those concepts, and then we'll start with the final state missions. Okay, try to complete all things by Sunday, at least by up to counters. Okay, don't put any pending.
Ma'am, when will protocols will start after SV or before SV? Just wondering.
Which one?
Just
Protocols.
protocols.
In Verilog, we will discuss one protocol, one project. Then in SV, we will discuss two protocols. In UBM, two protocols.
Okay.
Okay.
Okay, ma'am.
Do you want to finish fast? Then you can prefer recorded sessions
Okay.
if you want to complete fast.
Okay.
So, what is the output here? D equal to 0, D equal to 1 now. Output will be, if D equal to 0, output will be 0. D equal to 1, output also 1 only. Oh, here
But
why
it's
you
not.
it's
One
not
second, 1 second, 1 second, Prashanti. Not this, not this. I'll share another one.
bench. Yeah. Remaining, any doubts? Whatever the error you are facing, if you are not able to debug, you can also share your links if you are stuck in anywhere. Are you sharing, Sumlata?
Yes, yes. That's no, I actually removed. Well, it's the same only. It's okay.
Okay. So what's the
This-
error you are getting?
And not the error. I think I got doubt in the test bench itself only whether is it right or not. Output I didn't understand actually.
Reset. Okay, reset is 0. D is 0. Q also 0. Reset is high. Reset is high. Till reset is how you written the program. Reset is high.
Yeah, if not this program, the another. I tried in 2-3 ways, but
Initially clock equal to 0 at okay, if reset is high, output should be 0. If reset is 0, output should get Q equal to D. That's what the case. So
yes,
at a 10 time units reset, you are making it as a 1. So if reset is high, in this case, in this entire case, you will get a 0 only output because as your
yes,
condition, you will be getting
yes,
0. At the
yes,
30 time units, that means 10 plus 20, 30, 30 plus 30, 60. At 60 time units, reset is equal to 0. So here you will get the output. After reset is a 0, at a 60 time units, D input will be 0 only. So you will be getting output as a 0. 60 plus 40 at 100 time units, a D equal to 1. At that time, you will be getting output as a 1.
1. Actually, D is flip-flop, whatever the input data is the same thing output, right? Like that I expected, I mean, as per clock, with respect to the clock.
And that too, here you have kept a lot of clock cycles because you have written this repeat of
Yeah. That only here I got confused how to understand this. Can you explain a proper way?
Here you have written repeat of 10 at POSIX clock. So
I thought the D output will change like that. I added the repeat, but it is not. I mean, uh,
okay,
reset is not.
repeat of 10 positive edge of the clock. Inside only you are repeating, not like globally for all. Every change you are repeating 10 times. So
Okay.
if you write same repeat block after initial, it will be reflected to all. After entire process, then it will do 10 times repeat. But here you are doing initially clock equal to 0, repeating 10 number of times, and then repeat one reset d equal to 0. This thing you are repeating 10 times again.
Yeah. Can you correct it?
This thing, both are repeating 10 times. So that's why we are getting this out. Here 10 times repeating, here 10 times. Okay. So reset is high. Here output is getting correctly. Reset is high, output is 0. Reset is 0, input is 0, output is 0. Reset is 0, input is high, output is high. It's correct only. But you need to remove this repeat here.
Okay.
Initially, see, it is not repeating. Initially, reset is unknown and reset is high, but the D is not giving at the same time. D you given delays.
Okay.
It's not how to close this.
Save it after. Okay. Yeah.
Okay, see here reset is okay. At here it is going to 1 correct, but the D is after 10 plus 20 30 time units. D is updating as a 0 here. So here D is updating after 10 no, this 20 30 clock cycles.
Okay.
Next
Okay. So we
again
need to give the D also same time units.
same
That
time
means.
units. Remove
Okay.
this, like it's
Yeah.
enough, no need to give even 10.
Okay.
Then it will go to 10 plus 10, 20 time units
10.
D
Yeah,
will
again
get,
10.
but you can
Yes.
put like this. And here also remove this 40 at 30 time units, like this you can put. So all will come at the same time. Reset and D both at same time.
Okay.
Reset is high, so it is when reset is high, output is going to 0 as you written the
0.
code. Output is 0.
Yes.
So D is 0 with respect of this. Q is also 0, and reset is 0 at this point of time. D is also high at this same point of time. So it is just a delay. Q is getting a little delay, and D is 1. Q is also 1. And here we'll change another value also, D to 0, because here we written only D as a 1 value. We will change another value also here. Then you can also.
Next I have written for D Zero, I mean 1, right? Okay, one more
This
repetition.
one here
Yeah,
we need to change.
again it is coming the same program. Okay.
So here I'm making after 20 time units. D is equal to 0.
Okay.
So at 30 time units, reset is 0, D equal to 0. So you will be getting output as a 1. Next to 20 time units, D equal to 0, output is also 0.
Okay.
Like this. 1, 1, 0, 0. Like that 1, 1. Like that you can take. Okay. Clear now?
The
Any
next clock
confusion?
cycles, the down clock cycles.
Here I didn't did anything. Here down clock, any one is enough. 2 times it is
Okay.
repeated. Any one is enough.
Okay. Okay.
So
Okay.
if you see here, 0 after 60 time units, dollar finish. So till 60 time units, it will be in this case only, 0 case.
Okay.
There again,
See, if we want to write it in a structural model, means we need to use the logic gates, right?
structural modeling means the same D flip-flop counter you need to design, right? Which counter it
Yes,
is?
yes. A ring counter only, simple ring
Ring
counter.
counter.
Yeah,
Okay.
using D flip-flop, I just
Give the overall for ring data. There will be T as the input. Preset
yes,
clear clock.
and I'll
So
like
declare
this.
input and outputs. Whatever the D flip flops are there here, take the copies.
I just shared the picture, Prashanti. I just shared the picture.
Okay.
Can you?
Take the copies and just write those values, connections.
Oh, that only. Here we are not taking any AND or logics, right? That there I got out.
Here preset, reset didn't occur. Actually, we need
Yes.
to take
Okay.
preset and reset. That's
Okay.
compulsory. Why? Because those are initialized values. We need to initialize the value. First flip-flop
Okay.
will be connected to preset, so output will be go to set 1. Remaining all will be
Okay.
connected to clear. That means all will be 0. So first
Zero.
cycle will be started with a 1 0 0 0. Next one
Okay.
0 1 0 0. Next one 0 0 1 0. Like that cycle. So if you put
Okay.
in this case, you need to give input from the test bench. Then give
Oh,
D as
yes.
a
Yes.
test bench.
Mm.
Then check how it is getting.
Okay. Yeah.
In that case, how you will get the output? All will get one only, right? This one will be coming to here. This one will
Go.
be coming to here. One will be coming to here. Again one. So it will not, you cannot check with a ring counter. Also do one thing, Johnson ring counter. This instead
Yeah.
of connecting this Q0 here, connect with the Q bar, and same in
Okay.
test bench, give input as a 1 only. Then it will be reversing here. This 0 will be
Reverse.
connected to here. So there you can check the output properly in this with this diagram.
Okay. Okay.
Okay. Others? Any other doubts? Okay.
Yeah.
Okay then.
You are writing some program, sample program.
For which one?
By you are writing, right? Taking the 4D flip-flops.
Yeah,
Something you are
here
writing.
copy, just the same as a hierarchical multiplexer. Take the copies here. What are the values are there you shared in the chart box? D, Q. Input D, output Q. Another common input is a clock. Even you can connect this
Clock.
also, Q bar. Yeah. So input D. So same, however you are writing the path, I mean port list, same in the same way you need to connect the clock, reset, Q. Here you didn't mention Q bar, right? If you want to mention Q bar,
Yes.
first mention here Q bar, then only you can create the Q bar also,
Here-
because both the port
yeah.
signals must be equal.
Yes, yes. And
Okay.
again, that Q bar also we need to give the, I mean, that the
Yes,
last
next.
Q3 bar we need to give to
Yes.
the first flip-flop input.
First flip flop. Here we are mentioning D, right? For second one,
Yes,
you
yes.
need to mention as a Q1, next to Q2. For last one, Q3 bar, like that.
Yes, yes, yes. Yeah, okay. Thank you. I will try.
Yeah. Others? That's it.